to kick off, I'll just give you this intro to spaceKLIP. So here's a QR code and a link you can go to. It's an end-to-end reduction pipeline, so you can go from the lowest level like available data product you can get from MAST for near-cam and mirror coronography, all the way to products such as contrast curves, subtracted images, and companion fitting. It's heavily built upon two packages in particular, the official JWST pipeline and the PyClip package. It's open source and available on GitHub. Okay, so this is kind of the stuff that spaceKLIP can do. As an example for this ERS program we were a part of to image HIP 65426b, this exoplanet companion. And you can see here the picture of what I just showed a few slides ago, but for JWST. So on the left, we have these residual stellar light after it's passed through the coronagraph. And then on the right, we have what's happened after we've attempted to subtract away that residual stellar light to uncover the planet. And you can see the different techniques produce slightly different subtracted images that enable us to recover the planet to different degrees. We can also use spaceKLIP to create contrast curves. So this is an estimate, instead of looking at an image, you can say, okay, as a function of separation from the star in that image, how sensitive am I to a companion of a certain contrast or of a certain, flux level for the different modes here. And you can see where HIP 65426 is falling in those images. And then finally, it will do companion fitting. So we saw that picture of the planet a few slides back. What we can do is we can sort of model that PSF, that shape of the light for the planet, to kind of understand, how bright it is, what its precise location is in the image. You can see here, this is an example of spaceKLIP doing this for HIP 65426, and we're getting pretty good subtractions, I would say, with not too many leftover residuals at the end. Okay, so how does spaceKLIP work? Well, the bulk of it is through user inputs. You provide to spaceKLIP a whole list of instructions, essentially, of what you want it to do. And that gets loaded into this object in the code called the meta object. And I imagine this sort of like the puppeteer. This is pulling the strings or different parts of the code to tell it to do different things. And the way it does that is through, I would say, 5 primary stages at the moment. The first 2 are ramp fitting and image processing. This is those basic level steps, taking you from the lowest level data products you can get from the pipeline to images that you can start to do science with. And this is where we heavily rely on the JWST pipeline with a few tweaks of our own. And then there's this second chunk, which is sort of the analysis step, which is using PyClip and WebPSF, where we do the PSF subtraction, the contrast curves, and the companion fitting, like I just showed you. So the nice thing about spaceKLIP is it's not technically necessary to start right here at the ramp fitting. You could jump in a PSF subtraction if you have the images ready and they're in the right format. Or, if you trust the ramp fitting, you could go straight to image processing instead. It's really up to you, or at least that's how we hope to keep it working in the future. So setting spaceKLIP up, we have a couple of options. There's option 1, which is my preference, which is just you directly edit this huge config file. So this is, for those who are familiar, a YAML file. It just contains a whole list of, different options, and you can give it different instructions to do different things. Or the second option is you can edit the meta object I described directly in Python. So this is an example in like a notebook format, which I know some people are very fond of here, where we're just editing the different parameters as we go and running steps one by one. So now I'll give you the first sort of live demonstration of what that looks like. So I'll just, so hopefully everyone can see my screen now. You should see the 2 screens here and my folder on the right and the notebook on the left. So what we're setting up here, this is just, you'll be shared this tutorial after the presentation, but we're just sort of importing some libraries. We're saying from spaceKLIP.engine, we'll import JWST. This is our giant wrapper function that runs all the JWST reduction code. And then with that, we can start to initialize the code. So here, what we're doing is we're giving it a config file like I just described, that YAML file. And we're saying, pipeline, and we'll just call JWST with that config file. So just to make it very clear, this is the config file that we're loading in. This is what I just showed you a minute ago. We're just loading all these settings already in. You could also, load an empty file or a template file and edit as you go, which is kind of what we'll be doing here. Okay, now in terms of general setup, all we're really doing is setting up some directories. We're setting up a directory for the files that we're going to input to the code, which in this case, we're using this uncal444 data. So this is this folder I've put together here. So this just contains all the science and all the reference observations for these HIP 65426 observations I just showed for one filter, the 444 filter, which is at 4.4 microns. So if I open one of these up, you can kind of see, this is a DS9 image. I can change the scaling. We can't really see much right now, but that's what we're looking at. We want to turn this into those images of the planets I just showed you earlier. And we're giving it an output directory, which is just where we want to save anything. Here I just called it tutorial, so nothing's really there at the moment. We're giving it a stellar directory. This is just a file actually for the shape of the stellar spectrum. I'll touch on that later. It's pretty necessary for determining the contrast curve. And then we have a few options here for specifying run directories. This will become relevant later. And then some background subtraction directories. This is really for MIRI. I won't touch on that today in the live tutorial. I'm going to be exclusively looking at NearCam, although I will discuss MIRI in the presentation. We have a few general options like, do you want terminal statements to be printed out? Do you want to do plotting? Do you want to overwrite files that were already there? This is something to do with the NearCam bar mask, which we won't touch on today. And then we have a few little extra options here. So, what's the spectral type of the star? That's optional in spaceKLIP. It can be used sometimes. I won't cover that right now. We're specifying ahead of time RA off and declination off. This is the location of the companions that we know are in the system. This is used for masking later on. And then the error on our stellar magnitude in the 444 filter. So that's pretty much it. Some of these are optional, but that's really all you need to do to set the code up initially.